So I thought I'd do a short video on Docker Scout, what it is and how it works. But before I get to that, I do want to make clear that I am a Docker captain, so I'm not entirely unbiased here. And whilst it is a large free tier, Docker Scout is a commercial product with subscription options that kick in once you go past 3 repositories. Okay, so what is Docker Scout? So if you've heard of Docker Scout, you're probably thinking it's a vulnerability scanner, something like Trivy, Gripe, or Sneak. And it definitely is a vulnerability scanner, but do note that those words do not appear on this page. And the reason is, Docker wants Scout to be seen as a supply chain management tool, something that's constantly analysing your images against policies, rather than a CLI tool that you run once in a while. And in addition to analysis and vulnerability scanning, you do get a few more things. So Scout will actively give you recommendations on improvements that you can make, but it also has a policy engine that you can use to alert on different criteria. So for example, images with too many critical vulnerabilities, but also images lacking attestations or images that have copyleft licenses. And one thing that's not mentioned in this page is that there's also a lot of integrations available. So with various registries, but also with code quality tools like SonarQube, etc. Okay, so let's see how it actually works. To the terminal. So the first critical step in sort of analysing container images is to identify their contents. So the way we do that is to compile what's called an SBOM or software bill of materials. Now there is an existing Docker SBOM command, and that actually calls sift, which is a utility from Anchor. We're not going to be using that. We're going to be using the scout SBOM command that I assume will replace Docker SBOM at some point. We're going to ask it for a list format like the above from sift, and we'll start with Docker IO library Redis. Okay, so there we go. That was cached, I think, so it was very quick. Yes. Now, what it's mainly found is these .deb files. What it's largely gone and done is it's gone and asked the package manager inside the container which packages are installed. And that's what all these debs are. So that totally makes sense. But there are one or two other things. So we've got this Golang executable here for Gosu, which is basically a utility to change the user, a bit like sudo. And we also have a binary for the Redis application. So these haven't been installed by the package manager. They didn't apt-get install Redis. They were actually installed directly from a download, which is why they don't show up as debs. And we also have the libraries used by the Gosu utility. So that's quite a lot of output. We can take a look at the Alpine output as well for the fun of it. In this case, because it wasn't packaged, what's happened is Docker has actually got the attestation, which contains the SBOM for this package. So it hasn't downloaded the package, it just downloaded the attestation. And very similar. We have APK packages, because of course Alpine uses the APK packaging utilities. Again, we have Gosu and the Gosu libraries, and again we have the generic Redis library. There is a lot less in this image, which is just comparing Alpine and Debian really. Now the third one I want to look at is the Chainguard Redis image. I did have to do a little bit more work here because I had to pull and give the -- platform argument to download this version of Redis, and then if I run Docker Scout SBOM on it, I get this output. If I didn't download the platform specific version first, then I got a version that included OCI images that were coming from the SBOM attestation, and it was a little bit confusing. So I find this output a lot simpler. So this is just listing all the APKs in the Chainguard image. And the thing is, everything inside a Chainguard image is installed via APK. So this covers the entire image. So Redis, in this case, is installed via APK. And if we had Gosu, that would also have been in there. Okay, so now I guess it makes sense to look at the vulnerability scanning. So the command to check an image for vulnerabilities is Docker Scout CVEs. There's also Quick View, which just gives you a nice summary output. We're actually going to start with the Chainguard image. So in reverse order, because hopefully this shows us nothing. Yeah, so there's no vulnerable packages found in the Chainguard image. But the other images will hopefully show us a bit more. Okay, so it's actually found 54 vulnerabilities in the Alpine image, which I wasn't expecting, just to prove I do have the latest image. Normally, I would expect to see less vulnerabilities in the Alpine image. It's found 2 critical, 29 high, 13 medium, and 1 low vulnerability, and 9 that haven't been categorized. We can run this recommendations engine. I don't think it's going to say much for the Alpine image. Yeah, so it's got no recommendations at this time. However, let's take a look at the main Redis image. So this is the Debian based one, or Redis latest. And there's a lot more there. There's 75 vulnerabilities. And this time, if we run recommendations, I think it should have some recommendations for us. Yeah. So if I dig into this, and it looks a little bit better if you use Docker Desktop, I think its main recommendation here is, hey, why don't you use a stable Slim image? So this is very similar to the latest image. It's just got a few less libraries in it, and that brings your vulnerability count down by 23 low CVEs. The other thing that's worth being aware of is Docker Scout Quick View. So if I do Docker Scout Quick View Redis latest, I don't get all the output, I just get the summary output. And the recommendations, and the table with all the vulnerabilities and what we could change it to. So that's really quite nice. Now, what's next? Include policy results in your quick view. So we're going to move on to have a look at policies and what they are. But to be honest, that's best done in the browser. So we'll take a look at the web app. Okay, so this is Docker Scout, or a Docker Scout web app. And you can see immediately why they call it software, supply chain software, as opposed to just a vulnerability scanner. We have progressed towards various policies, and this is constantly updated over time. So we've got policies reflecting fixable vulnerabilities, high profile vulnerabilities, but also things like copyleft licenses and supply chain attestations. We can dig into the policies, and you can also start to define your own policies. I think that's only partly possible at the minute. I assume more policies and more configuration will be possible in the future. And it tells you, which images are compliant and which aren't compliant, and lets you modify policies and so on. If you look at the images for this sort of test, all I did was I pushed 3 Redis images and 1 Nginx image just as a test. So you can see the Chainguard one here with 0 vulnerabilities and the most policies in compliance. And here we have the Debian Redis and the Alpine Redis. Note I had to use different repositories for each image because by default it just picks up the last pushed image. Packages lists all the packages across your used images and how many images they're in use by. Vulnerabilities. So by default this is organized by severity. So we can try and find out what this CVE 2023 24538 and 24540 that are turning up are. And immediately I can see it's coming from the Golang standard library, which wasn't obvious to me from the command line output actually. So now I'm pretty sure what this is that the Gosu binary that Redis Alpine and Redis Debian version use is using a slightly old version of the standard library. So basically we need to do a new release of Gosu to pick this up. And that's why it's not in the Chainguard image, because we don't have the Gosu library by default. The other thing I want to mention is integrations. So there's a whole bunch of integrations available already for Docker Scout. You can see there's support for all the various repositories, and I'm already using the Docker Hub integration. That's how it picked up those images, but you can also get images from Azure, Artifactory, Elastic, and there's also support for various CI tooling like GitLab, GitHub Actions, Jenkins. Sysdig, GitHub, Bitbucket, GitLab. So a whole bunch of stuff there. Okay, so that's about it. Now there's a few things I really like about Scout. The first thing is, in the SBOM output you saw, it had not just the package manager files, the debs and the APKs, but also the binaries present in the image that had been directly installed, not via the package manager. And I strongly recommend testing whatever tool you use for creating SBOMs or scanning images to see if it can do the same, and make sure it picks up whatever Java jars or binaries you have installed in your images that didn't come from the package manager. The other thing I really like is the summary output. Now that sounds simple, but I honestly have struggled a little bit in the past with some other tools just to get the information that I want. And in particular, Scout is great at helping you finding the layers in which a vulnerability has been introduced, which can help you in turn mitigate them. Finally, the policy management and integrations mean that Scout is a tool that's worth trying to make part of your platform. Please give it a go and let me know what you think.